Good afternoon to you all.
Good afternoon.
So in the last class, we have discussed about one circle drawing algorithm known as Breseman's circle drawing algorithm. And also we have solved some numerical problems on that. Today we'll be discussing about another circle drawing algorithm called the midpoint circle drawing algorithm. Okay. So let's see how it works. So we know that for drawing any arc, we have to iteratively determine which pixels to make on in the next iteration. Suppose we would like to draw a portion of the arc like this, and in continuation of that, we can make a full circle. So let's assume that this is the portion of the circle, which is an arc here, from here. And at iteration, let's say k, we are at here in this pixel. So at iteration k, let's say this pixel is xk, yk. Okay. And our objective here is to determine which pixel is to choose in the next iteration. That means whether we will choose this pixel, let's say the pixel is the is t, which is xk incremented by 1 yk, because we are not changing the vertical direction, we are only progressing towards x-axis, horizontal axis. Therefore, the coordinate of this point at t in the next iteration will be xk. The x coordinate in the kth iteration incremented by 1. In kth iteration. So now another possibility, another point which we can choose is s. So these 2 points yk minus 1. That means since we are here in this point s, we are not only progressing in the positive x direction or positive horizontal direction, but also we are actually progressing towards the negative y direction. Therefore, the y coordinate is here decremented by 1, y minus. So I hope this point was also discussed in Breseman's circle drawing algorithm. So you are also familiar with this. So now here in midpoint circle drawing algorithm, the working principle is different from the Breseman circle drawing. Here it assumes that it works on the basis of the equation of the circle. Let's say the circle is centered at xc yc position. Okay. And this is the arc of the circle, means the radius of the circle, the r. Okay. So if the circle is centered at xc yc and radius is r, then we can write the equation of the circle as x minus xc whole square plus y minus yc whole square equal to r square, where r is the radius. Okay. So considering here, we are considering the xc and yc as the circle center. Okay. Now we can define a function considering the center at 0, 0. So if you consider the center at 0, 0 not as xc, yc, so then the equation becomes, then we can define the circle. We can define considering the circle center at 0, 0. So we can write the function of the circle as if circle, which is a function of x and y, can be written as x square plus y square minus r. Okay. The decision parameter may be defined. So based on this equation of the circle, we can make some decision. What is the decision? The decision parameter can be written as this form: f circle, which will be a function of xy, will be less than 0 if x and y is inside. If it is inside the circle, okay, then it will be equal to 0 if this xy is on the circumference of the circle. So on the circumference, and it will be greater than 0 if xy is outside the circle. So what does it mean? Basically, if we consider this is a circle. Okay, just I'm drawing with free hand, so it may not be a exact circle here. So if the point xy, let's say this is the xy, if it is inside the circle, then the function f circle will be will have lesser value, means the lesser value than 0. That means the negative value. If it is this point xy is on the circumference of the circle, then the f circle equation will give us 0 value exactly. And if it is outside the circle, then we will get the positive value. That means greater than 0. So now, based on this, we can decide which point to choose next. So let's assume that, assuming we have first plotted the pixel xk, yk at kth iteration. So assuming that we have plotted already, or we have determined the pixel at kth iteration as xk, yk, now we need to determine which pixel to choose in the next iteration. So assuming that xk, yk, we can name it also the point P. Okay, in the kth iteration, now our task is to determine which pixel that is xk plus 1, that means the t pixel t, yk, or the downside pixel that is xk plus 1, yk decremented by 1 in the next iteration, that is in k plus 1th iteration. Okay, so this we need to determine now. Okay. So for that, what we will be doing is that, so we will define a decision parameter. We will define a decision parameter. Decision parameter pk in the circle equation 1. Let's say this is the equation 1. This is equation 1, and we'll define that in this equation. Let's say this is equation 1. Now we define a decision parameter at kth iteration as follows. How we are determining the decision parameter? So just we will assume that we will compute the midpoint between this point T and point S. So what we are going to do is that here we are going to compute the midpoint between these two points T and S, and that midpoint value we will put here in this equation 1. So as follows, how we are doing? We compute the midpoint between the midpoint between the point T and point S. Point T, which is xk plus xk incremented by 1 and yk, and the point S, which is xk incremented by 1 and yk decremented by 1. Okay, so what will be the midpoint value? The midpoint value, let's say that is m. Okay, m value so midpoint will be somewhere here, somewhere in this position, somewhere here, exactly. Okay, so let's say this is m. So midpoint value will be midpoint value. What will be the midpoint value? It will be just, you just find out the midpoint value m will be, just you add the x coordinate values of the point T and point S. So that means xk plus 1, this plus again the x coordinate value of the point S divided by 2. So this will give you the midpoint value of the x coordinate, and similarly you will be getting the midpoint value for the this is representing the x coordinate value. Okay, and similarly you will be getting the midpoint value for the y as half of yk. Why it is yk? Because you see here the y coordinate value of the point T is yk. So yk plus the yk minus 1. So if you compute, you will get the value as here
So
this
you're
y.
copying.
Oh, sorry. So if you compute, you will get this as yk minus half, and this will you will get xk plus 1. Right. So these two values. So midpoint M will have the coordinate values what? Xk plus 1 and yk minus half. So this will be the coordinate of the midpoint M. Now this value, this midpoint M, if we put in the circle equation, that is circle equation 1, what we get, what we will get, and that is the basically the decision parameter at kth iteration pk is equal to f circle will be equal to the, here you see in the equation 1, the f circle was a function of x and y. Okay, so here the point will be not xy, but it is xk plus 1 and yk minus half. So by that way we get, what is the x coordinate here? Just wherever you will see x, just replace by xk plus 1. And wherever you will see y, you just replace it with by yk minus half in equation 1. So you get xk plus 1 whole square plus yk minus half whole square minus r square. Okay, so this is the decision parameter value pk. Where this is the decision parameter. pk is basically the at kth iteration. Okay. Now, from this, if we get that pk value is less than 0, then what does it mean? If pk value, decision parameter value is less than 0, what does it mean basically? If pk is less than 0 in this equation, what does it mean? What we actually can
Inside the circle.
understand from this.
Inside
Yes,
circle.
yes, true. So if that pk value, that means if this circle, if we put any xy value in the circle equation, and if you get that it is less than 0, that means it indicates that the point is inside the circle. So considering that concept in mind, so we can infer that the point which we put, that means the midpoint value which we put in this circle equation, actually resides inside the circle. Okay, so that if the midpoint, now look at the figure, if the midpoint resides inside the circle bound circumference. Now what does it mean? So this is the basically the M point, and the below downside point is basically S, and the upside point of the midpoint is T. So if you, in that case, if you choose the downside point, that is S, that will go further away from the circumference of the circle, which is actual circle. So in that case, which point to choose in the next iteration? In that case, we will choose the upside point T. In that case, we will choose the upside point T, as because that will be more close to the actual circumference of the circle. Because already the aim is inside the circle, and if you choose the downside point is as the next as the point in the next iteration, which will be further away from the circumference of the circle, which is the actual arc of the circle, compared to the point T, which is above the midpoint. So if you choose the point which is down the midpoint, so that will give you more error compared to if we choose the above point of the midpoint T. So therefore, in this case, we will choose the upside point T. So is this concept clear to you all? Please respond.
Yes, sir.
So if the midpoint itself is inside the circle, that means if you choose the downside point of the midpoint, that will go further away from the actual circle compared to if you choose the upside point of the midpoint. So therefore, we will choose in that case the point T. And so let us just write there. Then if pk is less than 0, then we can infer that midpoint, the midpoint is basically midpoint M, that is which is xk plus 1 and yk minus half, is inside the circle. Therefore, as the next point, that means xk plus 1 in the suffix, that means the x coordinate in the k plus 1th iteration, and yk incremented by 1 in the next. Okay. So that this is very much important, that in that case, if the if we get the pk value is less than 0, then we choose the point T, that is xk incremented by 1 yk as xk in the next iteration. That is in the iteration, that is in the k plus 1th iteration. Okay, now when pk is greater than equal to 0. So above the circle, means outside the circle, either outside or on the circumference. On the circumference case is the boundary case.
Sorry.
Okay, so midpoint if it is outside the circle, midpoint if it is outside the circle, you just see here, if the midpoint is already here, so then if you choose the upside point in that case, if the midpoint is here, and if you choose the upside point of the midpoint, okay, then it will, that means the point T, then that will go further away from the circle compared to if you choose the downside point, that is S. So in that case, what point we will choose? Which points we will choose?
Downside.
Yes, we choose the downside point, that means the point one as the point in the next iteration. Okay. Next iteration. So up to this point, I hope the thing is clear to all of you. So is it clear to all of you?
Yes,
sir.
sir.
So then, let's consider the first case. The pk is less than 0. So I'll be going to the next page here. If pk is less than 0, that means in that case what we are doing, then we are considering xk suffix, xk suffix, x k plus 1 in the suffix is equal to xk incremented by 1. Please mind the notation. Here it does mean that x k plus 1 in the suffix indicates that the x coordinate at k plus 1th iteration, and which is equal to the x coordinate at kth iteration incremented by 1, and y coordinate at k plus 1th iteration, that is y k plus 1 in the suffix, is equal to yk. Okay. So in that case, if we put these values, in the if pk is less than 0, then if we'd like to find out the descent parameter in the next iteration, that is the descent parameter, that means where? That means in k plus 1th iteration. What we get? Let's write that pk plus 1. So wherever you will be getting k, you just replace with by k plus 1. So you just see here. Here we see that the descent parameter was, let's say, name it equation 2. So xk plus, wherever you see the k, you just replace with by k plus 1. So just let me write that xk plus 1 was already there. Okay, whole square plus yk minus half whole square. So yk plus 1 minus half whole square minus half. By the way, if due to the time constant, if it gets disconnected, immediately join with the same link. So is it clear? So now here what we will be doing is that we will just replace this xk plus 1 with xk incremented by 1. So let me do that. So by doing so, what we will be getting? Xk in xk incremented by 1 plus 1 whole square plus yk plus 1 will be replaced by yk plus 1 is equal to yk, as you can see here. Oh, sorry. One thing yes, okay. So yk plus yk minus half whole square minus half square. Okay. Now, if you just do the calculation, and if you assume that this is A, and this is B, so we can do like this, that xk plus 1 whole square plus 2 into xk plus 1 into 1 plus 1 plus yk minus half whole square minus r square. So that is equal to, I mean, just rearranging, we can write, but just by rearranging, we can write xk plus 1 whole square plus yk minus half whole square minus r square. And so this part we have already considered. So what left? Left one is this one, that 2 into xk plus 1, okay, plus 1. So this part is left out. So we can write 2 into xk plus 2 plus 1. That means we can write that. Now you see here, this part is basically nothing but, equal to pk. Pk, what is the decision parameter? Pk is xk plus 1 whole square plus yk minus half whole square minus r square. So this part is nothing but pk. So we can replace it with pk plus 2 into xk plus 3. Is it clear? So this is the decision parameter pk plus 1 if the pk is less than. Okay. Now else part, else, that means if pk is greater than or equal to 0, then what we are doing? Then basically xk plus 1 we are considering as xk incremented by 1, and yk plus 1 we are choosing as yk minus 1. Okay, and if we just define the decision parameter in the next iteration, so in that case the decision parameter in k plus 1th iteration will be equal to pk plus 1 will be equal to what? Wherever you see, just replace it. Xk incremented by 1 plus 1 whole square plus yk plus 1 minus half whole square minus r square. Okay. So that hello. So if you just replace this xk plus 1 as similar to xk incremented by 1 plus 1 whole square plus yk plus 1. Now we will replace yk plus 1 by yk minus 1. Okay, because yk plus 1 in the suffix is equal to yk decremented by 1. So that we have replaced minus r square. Now, as similar to the previous case, we can just rewrite xk plus 1 whole square plus 2 into xk plus 1 into 1 plus 1. Okay, so plus yk minus half whole square. Just you see here, if you consider these two terms as a and this term as b, so you can understand that it is a formula for the a minus b whole square. So if you just do that, yk minus half whole square minus 2 into yk minus half into 1, okay, plus 1 minus r square. So just rearranging, what we can write is that, just rearranging, we can write that xk plus 1 whole square plus yk minus half whole square minus r square. That means this term, and this term we have already considered. So what left out is that this term 2xk, okay, plus 2 plus 1, and then 2 minus 2yk plus minus 2 into minus half, that means plus 1 plus 1. So that means what we are essentially getting is that, here I will be going, so pk plus 1 will be equal to, you just see here, this term is nothing but pk. So just let us write pk plus plus 2 into xk minus 2 into yk plus 5. Okay, just see here. So we can just write pk into 2 into xk minus yk plus 5. pk plus 1. Okay, is it clear?
Yes, sir.